So here is lesson 3.3. Here's your warm-up. So go ahead and pause the video and try this. So we're just reviewing FOIL, or the box method, or any of those, the area model, whatever method you want to do. So the answers to these: x squared plus 8x plus 16, x squared minus 16, or sorry, x squared minus 8x minus, or plus 16, sorry, and then x squared minus 16, and this one is x squared minus 25. These are special cases, that's why I had you do these. So they're kind of review, but these are special cases. We might have talked about these before, but I think we did. Remember when the first term is the same, and here the second term is, well, both of these second terms of these binomials are the same. Same with this one. So notice that we always have the middle here is double what these two are, right? Here we have first term the same, but second terms are opposite, and we have that our middle always drops out. First term the same, second terms are opposites, the middle is going to drop out. Those were our special cases. Okay, so here on this we want to factor in that same way, right? So if we see anything like these answers, so if we see anything looking like this, or this last one, then we know it's going to factor back to these ones, right? So we're kind of going reverse of those special cases. So as we look at this, we want to factor this, and you can still use CAB, and you could still use the box method if you wanted to, which is fine, right? If people are good at these, they can do it a lot faster without even having to do the box method or CAB or anything. They can just look at it and say, oh, I noticed that 6 times 6 is 36, and if I add those together I get 12, and then I just need to make both of them negative, right? Or you can still do CAB. 36, my B is negative 12. Don't pay attention to the negative at the beginning. Think 6 times 6, what times what gets you 36, but what plus what gets you 12. Then we'll come back and deal with the negative. So that's 6 and 6. So 6 plus 6 gets me 12, but I need a negative, so that means both of these need to be negative. Both of these are negative. When I take negative 6 times negative 6, I still get a 36. Okay, so that'd be x minus 6 and x minus 6. Oops. So notice those two factors are both the same. Now we divide by our a, which is 1. That's not going to change anything, so x minus 6 and x minus 6 is the factored form of this trinomial, quadratic trinomial. Okay, so once you get good at these, you can recognize, oh, that's a perfect, it's called a perfect square trinomial, right? Because this is x squared, it's 1x squared, and 1 and x squared is a perfect square, and 36 is a perfect square. So it's called a perfect square trinomial. And whenever you see that, it's going to factor really nicely where the two sides of my area model, 36, negative 6, negative 6, x squared, the two sides, x minus 6 and x minus 6, are the exact same. That's why it's a perfect square, because the two sides are the same. Alright, go ahead and look, check at this one out. Is it probably going to be the exact type as the last one? Yes, but you could still do CAB if you wanted to. Okay, so do it however you want to. Okay, so I noticed that if I take this number and square root it, I get 3, right? What times itself? When you're looking at perfect square trinomials, it's a perfect square, so that means something times itself gets you that number. Okay, so what times, what times itself gets you 9? That's 3. And now if I take 3, if I have 2 3's, does that get me to 6? Yes, it does. So x plus 3 and x plus 3. Okay, you can still do CAB. your b. What times what is 9? 3 and 3. And 3 plus 3 is 6. So I get x plus 3 and x plus 3. That's the factored form. And so here are the key concepts. Basically, this is kind of like the formulas. Right? These are the formulas. So if you see something like this, all right, if you see something like this, then you can always factor it to these. Okay? So what that means is, so for example, you always have something being squared. So that could be a x squared, it could be a 4x squared, it could be a 9x squared. They're perfect squares. 4, 1, 1, 4, 9, 16, 25, 36, 49, 81, or 64, 81, 100, right, and so on. Those are perfect squares. So if I have any of those numbers as my A or my B, usually your A is going to have one of these, maybe one of these numbers and an x squared or a squared or a b squared or a c squared or an m squared, right? Your b squared right here is probably just going to be one of these numbers, okay? So if you take those numbers, one of these numbers that's for a and for b, and if you square root it, you find what times what equals that number, and then you times those together, and then times those by 2 if you get your middle that way, then you know it's a perfect square trinomial, and it'll factor this way, right? If I take this and square root it, I get x. What times what is x squared? That's x. What times what is 16? That's 4. Now if I take those two and multiply them and times them by 2, do I get the middle? Yes. X times 4 is 4x. 4x times 2 is 8x. So that means it's going to factor just like this. It's a different way to do CAB. But you could still do CAB. What times what is 4? That's a 2. What times what is n squared? That's an n. What times what is 9? 3. So then what's 2n times 3? That's a 6n. It's a 6n, and then times that by 2, I get 12n. But this is negative, so that means that these both need to be negative in here. That's the only difference, right? So if your middle's negative, that means both of these would be negative. If it's positive, then both of them would be positive. Okay, so that's how you can kind of use this. Again, you could just do CAP and you'd be fine. Okay, so reading through this problem, I think we did this maybe before a little bit. But we're trying to find this pixel, and this pixel, the area, that's A, the area of the pixel is 4x squared plus 20x plus 15, and now we want to find the sides, right? We want to find the length of one side of the pixel. And it says that it's referred as squares, right? So that means we have squares. So it means both of these sides will be the same. So that kind of gives us a hint that it's probably going to be this is a perfect square trinomial. So again, you could use CAP if you want to, but if you notice, what times what is 4? What times itself is 4? That's 2. What times itself is x squared? That's x. What times itself is 25? That's 5. Now if I multiply these and times it by 2, do I get my middle? What's 2x times 5? It's a 10x. 10x times 2 is 20x. So yes, multiply them together and multiply them by 2 gets me the middle. So that means this would be one of my sides. 2x plus 5, because it's a positive 5, because it's positive in the middle. So there would be one side of the pixel. Okay, so different scenario here, right? Building a square, that means both sides are the same. Patio, and you're given the area of the patio as this quadratic trinomial. Now find one of the sides. So go ahead and pause the video and try it out. Okay, so you notice that 16 and 81 are perfect squares. Well, what times what is 16? Or what times itself? 4. What times itself is 81? 9. Now I have to look at the m squared. What times itself is m squared? That'd be 1m. Now if I multiply these together and I times it by 2, do I get my middle? 72. 4 times 9 is 36. And I have an m in there, so 36m. Can I times it by 2? Do I get the middle? But it's negative, right? So since it's negative here, that means these two sides would be 4m minus 9. 4m minus 9. So those is one of my sides. The other side would be the exact same thing. Okay, if you want to, you could try to do completing this, or not completing square, sorry. You could try to factor this by using CAB if you want to. Your b, your middle term here, your b would be 0. Okay, so you think about CA. What's your CA that adds up to 0? Right, so what is negative 9? Negative 9 that adds up to 0. So you could try that, or you could try to use what we've done before from our warm-up, the very last two. What are the two factors going to be? Okay, so whenever the middle's gone, that means you're going to have one positive, one negative, and then what times what is z squared? That's a z and z. And what times what is negative 9, or 9, just think 9. What times what is 9? That's times itself, 3 and 3. So z plus 3, z minus 3. It's called the difference of two squares. This is being squared, z is being squared, and 3 is being squared. Difference of two squares. Okay, go ahead and try this one yourself. Okay, what times itself is v squared? That is v. What times itself is 100? 10. Since the middle is missing, that means you're going to have one positive and one negative. Again, you could do CAB, that's fine. So here is the little formula sheets that you can do, that you can use. Okay, so whenever you have something being squared minus something else being squared, it always factors to this. One's positive, one's negative. So here x is being squared, here 8 is being squared, and then we have no middle, so that means one's positive and one's negative. Here, what's being squared? X is being squared, and 5 is both being squared. And what's being squared here? That's 6. And then middle's missing, so one positive, one negative. Okay, so go ahead and try this on your own. Pause the video and do this. What's being squared here? 4 and x. What's being squared here? 9. Middle's missing, so 4 plus 9. Or sorry, 4x plus 9 and 4x minus 9. Okay, go ahead and try this one on your own. What times itself is 25? What times itself is d squared? What times itself is 64? And one positive, one negative. So you can see these get pretty fast. You can do these pretty quick. Okay, go ahead and factor out the greatest common factor first. I probably should have told you that before, but that's okay. Because what you notice is these are not perfect squares, right? The one I had 25 and 36, those are perfect squares. 24 and 6 are not perfect squares. So what could I factor out of those to get perfect squares? So that'd be a 6, right? So I can factor out a 6. That means I put a 6 on the outside. I get 4g squared minus 1. Now 4 and 1 are perfect squares. What times itself is 4? 2. What times itself is g squared? G. What times itself is 1? That's still 1. And then middle's missing, so I have a plus and a minus. But just remember, you have to put this 6 still on the outside, okay? Alright, go ahead and try this one on your own. Factor out the greatest common factor first, so you have perfect squares, right? 12 and 48 are not perfect squares, so factor out the greatest common factor first, and then you will. Okay, go ahead and pause the video, try it. Okay, what can we factor out of 12 and 48? 12. So we factor out 12, we get left with a t squared minus 4. What goes in, what times itself is t squared? That's t. What times itself is 4? That's 2. 1 positive, 1 negative. Make sure you put the 12 out in front. All done. Okay, so that's it. That's all of them. Go ahead, watch the video as many times as you want. Send me a message on Edmodo if you have any questions with any of the homework problems or anything like that. All right.